Hello! Alright, we're doing section 7.6 out of the Big Ideas textbook. Today, just the main learning targets, nothing actually from the book. I don't think. I just picked the problems. Just came up with them. So, we're factoring polynomials of the form ax squared plus or minus bx plus or minus c, where the difference here between 7.5 is we have a coefficient that is not 1 in front of the x squared. So, we're going to use some of the stuff that we talked about in 7.5. It's just extra couple steps. So go ahead and write that down if you're Cornell noting it up, and we'll get going. Here are our examples. So the first one, and the instructions are to factor, and remember factor means write a multiplication problem. So our task here, our goal, is to take each of these trinomials and write them as a multiplication problem, something times something. And in order to do this, we're going to use that area diagram, the box method. It's just going to be slightly different than if that was a 1. So we draw our area model. And we know whenever we do this, the way we've been doing it, the 4x squared, so the x squared term goes in the top left, the constant term, the negative 5, goes in the bottom right. Make sure you're bringing it down as a negative 5, so you got a minus there. Say, hey, these two things, we don't know what they are, but we know that they are going to add to negative 19. And they're each going to have an x. But there's a lot of numbers that add to negative 19. Oh, don't do that. We need them to multiply to something as well. But because we have this 4x squared here, it's not just multiplying to negative 5 like it was in the previous problems. It's going to multiply to the product of these two. So it's going to multiply to negative 20. And I showed that with when I did the whole ax plus b times cx plus d. And each box had a, b, c, d if you multiply them all together. So it always works. If you're multiplying two binomials, the product of these two boxes is the same as the product of those two boxes. So whatever goes here, these two numbers have to multiply to the product of these two boxes. So 4 times negative 5. So in other words, these two need to multiply to negative 20. And they need to add to that middle term. So let's find those numbers. And we always start with, hey, what multiplies to that? In this case, what multiplies to negative 20? Well, we could think like 5 and 4, one positive, one negative, but those don't add up to negative 19. So 10 and 2, nope. But 20 and 1 multiply to 20. I need to multiply to negative 20, so it's either negative 1 or negative 20. I need it to add to a negative 19, so I'm going to make 20 the bigger number, a negative. So we go to negative 20 plus 1. Negative 20 minus, times 1. Not minus, times. Right, so that lines up properly with what we set up. These are the numbers that go in our box. So now we are not done, this is a more involved process. So you say, well, what multiplies to give us those pieces inside that box? What I like to do is I like to start with the top left with the x squared term up here and say, what times what gives me 4x squared? Well, I know it's going to be an x times an x, because that's x squared. So I just put the x's there. Boop, boop. I think what multiplies to 4? We got 4 and 1, we got 2 and 2. Don't want to use 2 and 2, because if I put a 2 here, I'd have to say 2x times what gives me 1x. That would mean I'd have to put a half here, I'd have to use fractions. No thanks. So I don't want to go 2 and 2. I want 4 and 1. If I put the 4 here, then I got 4x times something equals 1x. I'd have to put a fourth there. No thanks. So what I'm going to do is I'm going to put the 4x here lined up with the negative 20. And I'm going to put the 1x here lined up, well, with the 1x. So now I say 4x times what gives me negative 20x. So 4x times negative 5 gives me negative 20x. I multiply those. 1x times what gives me 1x? Well, just a 1. And that's positive, so it's plus. If you didn't get this, you could say negative 20 divided by 4 is negative 5. You use divide to get that number. And then double check, hey, negative 5 times 1 is negative 5. So here, the answer, because remember, we are factoring, the answer is going to be the multiplication problem. So it'll be x minus 5, we don't need to write the 1, and then times 4x plus 1. We're happy. Yeah, that's good. That's it. That's a multiplication problem. You could multiply it through. If you were to multiply these, you would just do this. 4x plus 1, x minus 5. Multiply, multiply. You'd get that. Awesome. Let's do a couple more examples just to get the strategy down, and then, well, then that'll be it. Let's switch colors too, because that's fun. Here we go. 6x squared minus 10x minus 4. Step 1. Draw your area model. Throw the x squared in the top left, the 6x squared in this case. We're going to put the minus 4 in the bottom right. The constant goes in the bottom right. Don't forget that it's a negative because it's a negative. And then here we got to find two numbers that add to this negative 10. So that's going to go here and here. We know our x's, our regular x's are going to be there. We just got to find the numbers that go with it without too much guess and check. We're taking educated guesses. And then we know that these two numbers need to multiply to whatever those multiply to. So 6 times negative 4 is negative 24. So here I need two numbers that multiply to negative 24 and that add to negative 10. Go ahead and pause the video in a moment and just try to find those numbers. Hit pause. Try it. If you didn't hit pause and try to find the numbers. I'm going to do it. Okay, we're back. Unpaused. So, two numbers that multiply to negative 24. Well, we know 6 and 4 multiply to 24, but if I add a negative 4 and a 6, that gives me 2 or negative 2. That's not what I want. 24 and 1? Nah. 12 and 2. Which one should be positive? Which one should be negative? Well, they got to add to a negative, so we're going to make the bigger number, the 12, the negative. So a negative 12 and a 2, a negative 12 and a 2. So I have a negative 12x and a 2x. All right. That lines up. That's nice. Those add to that. All right, cool. So now we got to figure out what times what gives us this area model. So starting with the 6x squared, I know x times x is x squared. And I think what times what gives me 6? Well, it could be 6 and 1. If I go 6 and 1, and this is good to think about it first, like 6 and 1, it'd be like 6 times what gives me negative 2. Well, that's I got this negative 2. 6 times negative 2 is negative 12. 1 times 2 is 2, right? And then, oh look, there it is. Now, what if we did this? 3 times 2. So if I go 3x and 2x, well 3x, right, sorry, 12 divided by 3 is negative 4, so a negative 4 there. 2 times 1 gives me 2x. Oh, that works too. Now notice, these are all positive. Well, they're not positive, sorry. These are all even numbers, they're all even. So we could have divided by 2. Could have divided by 2, sorry, factored out a 2 in the beginning. Because notice we have the 2x minus 4 and the 3x plus 1. So we could either have 2x minus 4 times 3x plus 1, or we have that 6x and x, right, 6x plus 2, and then x minus 2. Well, there it is. Notice the 2 and the 4 are both divisible by 2. The 6 and the 2 are both divisible by 2. So we can factor a 2 out of that. It's a little complicated, but divide out 2. So 2 times x minus 2, divide out that 2, divide out that 2, times 3x plus 1 is the same as if I divided 2 out of here. 2 times 3x, because 6 divided by 2 is 3, plus 1, and then times x minus 2. Alright, so the same answer, depending on who your teacher is, they might be looking for this answer, they might be satisfied with that answer. Double check with your instructor before like writing one of those on a test. Alright, If it's like factor, 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 if it says factor completely, we're looking for this, where you pull out that number at the end. Would have been easier had we pulled out that number in the beginning. Sorry. So look for that. Keep that in mind. Problem 3. So here we have 8x squared plus 22x plus 5. Draw the box. Whoop, 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 whoop. So here, 8x squared, we put our squared term in the top left. Put 5. It's positive, so it's just 5. Bottom right. Say we need two numbers that add to the middle term, which is 22. Two numbers that multiply to the product of those, which is 40. What multiplies 40 and adds it to 22? Pause it, figured out. Boop, 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 boop. Correct, it's 20 and 2. So we're going to go 20 times 2 is 40. 20 plus 2 is 22. So here I got a 20x and a 2x. There goes my pen. So now we just figure out what times what gives us that. Well, I could either have 8 and 1 or 4 and 2 to multiply to 8. All right, we know we're going to have an x for each one. Now, if I had an 8, the 8 does not divide into 20, 8 does not divide into 2. Don't want that. So I want 4 and 2. 4 divides into 20, and 2 divides into 2. So I'm going to go 4x times what? Oh, this is exciting. Times 5, and then 2x times 1. So here, 4x plus 1 times 2x plus 5. That's our answer. Looks a lot like that one. Similar. So, that's that. Do lots of practice to get good at these. Remember, the idea is you draw your area model.